All right, welcome to week 3 lesson for the ACT Math prep class. First thing we're going to talk about is scientific notation. All right, basically, scientific notation is a shorthand of writing a big or small number. It's just a way to write a big or a small number without using too much writing. We don't want to write a bunch of stuff, so in order to do that, we're going to use scientific notation. So the rule is you got to have one number in front of the decimal. We've all seen stuff like this: 3.58 times 10 to the third power. Okay. Now, if we were to write that as an actual number, of course, remember you can always add zeros before and after, as long as there's a decimal place here. So 10 to the third means it's times basically 10 to the third is 1,000. So if I took 3.58 times 1,000, really it would just move the decimal over 3 places and make it 3,580. Okay, if we had a similar number and we were doing times 10 to the negative third, we would put our zeros in front, and then we would move it 1, 2, 3 places. So 0.00358. Okay. Scientific notation is just a way to write a big or a small number. You can tell if there was a bunch of zeros, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. It's 1 times 10 to the 10th because I moved 10 places. You can see how this starts to get pretty convenient. Instead of writing all those zeros in that one, it's going to save you. If you had 100 zeros, you wouldn't want to write out 100 zeros. You want to put 10 to the 100th power. All right, so that's the idea. So here's basically how it works. Anytime you have a number like 562.3, okay, and I'm going to write this in scientific notation. What you have to remember is this is 562.3 is really 562.3 times 1. Excuse me, times 1. 10 to the 0 is 1. Anything to the 0 is 1. So if you can think of it like this, every number is kind of written in sort of this almost scientific notation way. Every number is times 10 to the 0 because 10 to the 0 is 1 and anything times 1 is just itself. So then what you have to do is you have to say, okay, if I basically move the decimal place 2 places over, okay, I need to then multiply by a power of 10. So if I made this number smaller, see how I had a 562 and I brought it down to a 5? If I make this number smaller, what I have to do is then make this number bigger. So by the same number that I moved over in decimal places, I need to raise that to a power. So this is the same number, but what I did was I made this number here smaller, so I counterbalance that by making this number bigger. Now, what if I did it the other way, 0.00036, okay? Remember, this is technically 0.0036 times 10 to the 0. 10 to the 0 is 1, so it doesn't really change anything. So if I move my decimal place 1, 2, 3, 4 spots, remember I need to have one number only in front of that decimal. So if I move this to 3.6, notice how I made this number bigger? That means I need to make this number small. So the way to do that is to do a negative exponent. So 1, 2, 3, 4 places means I need to make that a negative 4. So what I did was, if I make this number bigger by doing this, I have to make this number smaller. And remember, 10 to the negative 4 is 1 over 10,000. That's a small number. Okay, so that kind of balances out. So scientific notation is like a balance. If you make one number bigger, you got to make the other number smaller to keep it the same. Okay, now all this can be done on your calculator. The only trick is, so I could do any number like this. Let's say I'm doing some kind of operation, 58 times 65, and I get this number. Well, I want that number to be in scientific notation. Okay, if I go to mode, you'll see here under Sci, that's scientific notation. So if I go over to Sci and I hit enter, now I'm in scientific notation mode. So when I go back and I do the same operation, 58 times 65, actually before we do that, let's look and see what it would be. So 3,770 is our answer. So 3,770, remember the decimal place would go right there. So this would be 3.77 times 10 to the something. Now, 1, 2, 3, 3 places, so it's either positive 3 or negative 3 as the exponent. And what I did was I made this 3,000 smaller, so I have to make this number big, and 10 to the third is a big number versus 10 to the negative third, which is a small. Okay, so we know it's 3.77 times 10 to the third. So let's see what our calculator does. Now that I hit enter, I get 3.77. It doesn't say times 10 to the third, but it does say E3. You have to remember that E3 means 10 to the power of 3 times 10 to the power of 3. So when you see that on your calculator at the end, that little E3, that's when it's doing scientific notation. Okay, so just a quick reminder, second mode is quit, but if you just hit mode, you're going to get to the different modes. Normally we want this thing in normal mode, but if you want to use scientific notation, you put it in scientific notation. All right. So with that said, you can do all kinds of things. You could do 3.75 times 10 to the 6th times another number, 2.1 times 10 to the negative 15th. You could do that multiplication on your calculator. Okay, just make sure you're in scientific notation mode. It's going to give you the correct answer. So anytime you're doing multiplication, division, addition, any kind of thing with scientific notation, I would just use my calculator in scientific notation. Okay, next topic, we're going to talk about some fractions. So these are really, really basic fractions that you need to know. So you need to know that 1/2 is 0.5, which is just 50%, right? A third is 0.3 repeating, 0.33333, which is just 33.33%. 1/4 is 0.25, which is 25%. 1/5, 0.2, which is 20%. 1/10, 0.1, 10%, 1/100th, 0.01, 1%. So if you need to, pause this, look it over, make sure you really understand that. These are things you have to be able to memorize for the test. They're just basic facts that you got to know. Okay, so what we're going to start talking about now is the percent part. Okay, now the word per means to divide, and the word cent means 100, right? You think about centipedes, they have 100 legs, cents, 100 cents in a dollar, century, 100 years, so anything cent. So when you say percent, you're literally meaning divide by 100. That's kind of what percent means, okay? So just kind of a background on what that word means. All right, moving on. All right, so first thing you got to be able to do is you got to be able to find basic percentages of a number. This strategy is really important for things like doing work in your head, okay? So let's take the number 35. If I said find 10% of 35, okay, you got to be able to do this pretty quickly. Well, 10% literally means 10 over 100, which means 1/10. Well, when we're in powers of 10, that means move the decimal over. Long story short, this 35, I'll add the 0.0 just to show you where the decimal is. Move the decimal one place. 10% of 35 is 3.5, okay? Just move that decimal place one over. So same thing, if I have the number 35, what is 1% of 35? Well, here's your decimal place. Move it over 2 places. It's 0.35, okay? Got to be able to find 10% and 1% of a number very quickly. Either move the decimal 1 place or 2 places. Now, where does that really come into play? Let's say I want to know 17% of 40, okay? Well, 17% is really 10% plus 5% plus 1% plus 1%, right? If I break down that 17, it's 10 and 5 and 1 and 1. So what's 10% of 40? That's 4. Right? 10% of 40 is 4. Just move the decimal over 1 place. Now think about 5%, right? Compare it to 10%, right? 5% is just half of 10%, which means all I need to do is take half of 4. So make sure you understand this. Pause this video and take a quick look. But if we're looking at half of this percent, we should have half of that number. Okay? So if you can find 10%, you can find 5% really easily. You just cut it in half. Okay, 1%, we know we move that decimal over 2 places, so that's going to be 4. Again, remember my 40 has a decimal place here, and I move it over 2 decimal places, that's 0.4. So then again, I get another 0.4. So what I do is I just add up my percents to get 17. So when I want to know the value, I just add up my numbers here. So 4 plus 2 plus 0.4 plus 0.4, that makes 6.8. So 6.8 is 17% of 40. Now, you can obviously use your calculator here, and I'll show you how to do that. It's pretty easy as well, but it's still good to be able to do those basic operations pretty quickly in your head. So if I wanted to know 17%, I would write 17% as a decimal, and then I would multiply that by, whoops, that's not the multiplication symbol, 17% of 40. We would just multiply 0.17 times 40, 6.8. So again, you can use your calculator, but it's still pretty good to be able to do some of these calculations pretty quickly in your head. Okay? All right. So moving on. Next thing you got to be able to do is convert a decimal to a percent. So if I give you a decimal, let's do one of those ones from earlier. Let's do 0.25. That's my decimal. I want to convert that into a percent. Now, if I go back and look, right, 0.25 was 25%. So how did I do that? Well, I just multiply by 100, okay? That gives me 25%. So although percent means to divide by 100, you've got to remember to change it from a decimal to a percent, you multiply by 100, okay? Now what if I want to go the other way? What if I want to go from a number like 25% to a decimal? Well, I divide by 100, okay? And that's going to give me 0.25. Okay, so this is from a decimal to a percent, we multiply, and from a percent to a decimal, we divide. Now, here's how I remember this, December, okay? December. I notice that I wrote that wrong. Helps me remember a decimal, I multiply. Decimals, you multiply. From a decimal to a percent, you multiply. So December might be one way to help you remember that. Okay, moving on. So big part of the test. I mean, I definitely say you're going to see some problems on the test that are like this, or what we call solving number sentences. Or they're kind of like word problems, I guess. So we'll say solving word problems that involve percentages. Okay, so we're talking about word problems that involve percents. So first off, you got to just know the language, okay? The basic language is this, the word of, okay? The word of means something. What does it mean? The word of means multiply, okay? When you see the word of, you got to remember ding, 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 that's multiply. All right, when you see the word percent, you've got to immediately connect that to mean divide by 100, okay? When you see the word is or the word equals, you've got to remember that that is the equal sign, okay? And finally, when you see the word what or what number, okay, that's where we're going to use the variable. So you can pick any letter you want, but we'll just go with X. Okay, so of means multiply, percent means divide by 100, is or equals means equals, what means X. Okay, so what we're going to do is we're going to take word problems that deal with percentages and we're going to convert them into equations by doing this. All right, so let's look at an example. What is 30% of 65? What is 30% of 65? Okay, let's do it. What does what mean? What means X? Okay, what is? That's equals 30%. Now the number 30 you just write down. So you're going to write 30, but then percent tells you to immediately divide by 100. So I'm going to immediately divide that by 100. Okay, 30 over 100. Of means multiply, and of course 65 is a number that we write just as 65. Okay, so this is something I can just type into my calculator, all right? 30 divided by 100 times 65. So 30 divided by 100 times 65 gives me 19.5. Okay, so x is equal to 19.5. Now, if you really think about this, 30% is actually pretty easy to do by hand because we know what 10% of 65 is, right? It's 6.5. And if I want 30%, I want 3 10% added together. So what happens when I add 6.5 and 6.5 and 6.5? 6 and 6 and 6 make 18. A half and a half make 1, and another half makes 0.5. Add those together, you get 19.5, which we knew was our answer. So again, there's another reason why, hey, instead of breaking out your calculator, you can think about that one pretty quickly. All right, now just don't forget the strategy here is to take the word problem, convert it into an equation that you can solve by using these keywords here, of, percent, equals, and what. Okay, let's try another example. What percent of 50 is 75? Okay, all right, let's convert it. What? That means x. Percent means to divide by 100. So whatever was right before the word percent, you're going to just divide by 100. Of means multiply. 50 is just 50. Is equals 75 is 75. Okay, what percent of 50 is 75? Okay, so we've done it. We've converted to an equation. Now we just have to solve the equation. So a couple things here. I want to start getting rid of numbers. So see that times 50? I want to get rid of that. So I'm going to divide by 50, right? If I divide this by 50, and if I divide this by 50, this goes away, and I'm left with that number there. Now, how do I get rid of this 100? Well, I multiply it away. Okay, since it's division, the opposite of division is multiplication. So to make it go away, I have to multiply. Right, that's the only hard part of these. Once you convert them, then you just got to make sure you can get to here. So I'm going to type this in my calculator. 75 divided by 50 times 100. All right, we get 150. So what percent of 50 is 75? It's 150%. Now think about that. What's 100% of 50? 100% of 50 is just 50. Well, what's 50% of 50? Well, it should be half of 100%. So half of 50 would be 25. So you can see if you add these together, you get 150% is 75. So yes, 75 is 150% of 50. Okay, so one thing you want to make sure you do is make sure that answer makes sense. Okay, you convert it into from words to an equation, solve the equation, but then you have to make sure that number makes sense. Does your answer make sense in the problem? If it's all crazy, you might want to rethink it. Okay. All right, last problem. 30 is 15% of what number? Okay, there we go. 30 is, so 30 equals 15%. So 15 divided by 100 of what number? Okay. So a couple ways to do this one. You could go ahead and change 15 over 100, right? That's an easy one. 15 over 100, if you type it in your calculator. Remember, you can always use your calculator if you're not sure, but you should be able to do this one by hand. 15 divided by 100 is 1500, so 0.15. So you can go ahead and convert that into that decimal number and then just divide it out. Since it's multiplication here, right? Since we're multiplying here, we do the opposite, which is division. So just 30 divided by 0.15. Okay, 30 divided by 0.15 gives me 200. So x is 200. Now, does that number make sense? 30 is 15% of 200. Well, 15%, that's another easy one, right? 10% of 200 is 20. 5% is 10. So yeah, 15% is going to be 30. So that makes sense. All right, let's see. If you did not see this part here as changing that to 0.15, you could alternately do these two steps to get rid of the 15 and the 100. You could get rid of the 100 by multiplying by 100. Since we're dividing by 100, you could multiply by 100. That gives you 15x. Then you divide out the 15. Okay, since it's multiplication right there. So you could do 100 times 30 divided by 15. You're still going to get the same answer. Okay, same thing. All right. So what you need to remember is that 20% more of something, okay? If you add 20%, like a fee or a tax or something, if you're doing 20% more, what that really relates to is 120%. Because you have to take into account the original amount is 100%. So if you do 20% more, you're really doing 120%, okay? Also, you need to remember something like 15% less, okay? For instance, like a discount or a sale. That's just really gonna bring it to 85%, okay? So those are just things you gotta kind of remember. There'll be things that'll come into play here and there. All right, next thing I want to talk about is percent increase or percent decrease. So I'm going to use inc and dec. Okay, but that's increase and decrease. Okay, basically it's the amount of, it's the relative amount of change. So for example, right, Bill Gates, richest man in California, drops a $100 bill. He doesn't even stop to pick it up because relatively that $100 does not mean much to him. If I drop a $100 bill, I'm going to pick it up. Okay, that is percent change when you look at examples like that. All right, so let's look at the formula. Basically, there's just a formula for this. The formula for percent increase is the change, the amount of change. So how much ever you go up or however much you go down, whatever that increase or decrease is, we're just going to generalize that as change. So the change over the original times 100. Now, we see this times 100 quite often. What does the times 100 do? That makes it a percent. Okay, when we multiply by 100, we're making that a percentage. So let's look at an example of a problem like this. All right, what is the percent increase when I go from $600 to $800? Okay, let's say I get a $200 bonus at work. I had $600 in my bank account, I put it in there, now I have $800. So I want to know what is the percent increase, okay, from 600 to 800. All right, so our formula says it's the change. So what was the change? How much did we change here? I went up $200, okay? We divide that by the original amount. So what did we start with, right? We started with 600. Then I'm going to multiply that by 100 to make it a percentage, okay? 200 divided by 600, which does reduce to 1/3, is 0.3333 repeating. If I multiply that by 100, I get 33.3 repeating, or 33 1/3. Now remember, this is a percent. I need to make sure I label that as a percent. So that's basically it for percent increase, okay? One thing to remember is if you see percent change, okay, you won't usually see percent change, but if for some reason you did, then the sign would make a difference here. So you'd have to make sure that this was a plus 200. A positive number means that it is an increase, okay? Normally though, if you do percent decrease, let's say you go from 800 down to 600, okay? So let's work that problem real quick, okay? If you go from 800 down to 600, so how much did you change? You still changed $200. Okay, now remember, percent decrease and increase, we don't worry about the sign. So we don't have to put a negative here. We only do that with percent change. If it said, what is the percent change? I would have to make sure that I used a negative there for my 200, okay? But since we're not doing percent change, we're just doing percent decrease, we're not gonna do that. All right, so the change was 200. The original amount now is 800, okay? So that's going to be a little bit different now. Some people would think, oh, it must be 33% and a third percent, but it's not. This is going to give you a 25% increase. And think about that. 25% is a fourth. I went up, or excuse me, I went down a fourth. So this is a 25% decrease. All right? Just the only thing you have to remember is this formula. Change divided by the original times 100. And if you do percent change, you would actually do negative 200 over 800 times 100. So that would give you negative 25%. That's the percent change, right? This is the percent increase. Okay, it doesn't matter about, or excuse me, the percent decrease. But the point is, percent increase and percent decrease don't carry a sign. Whereas percent change, if you go down, you have to make sure you include that negative sign. All right, moving on. Next is ratios. All right, so a ratio is just a comparison of two things. Okay, when I compare two things, I'm looking at a ratio. I'm going to put an R in there. Comparison of two things. Okay, so the example would be, what's the ratio in this rectangle between the length and the width? Well, the ratio would be the length compared to the width. So one way we write a ratio is like a fraction. So that's the ratio of length to width, L divided by W. All right, a lot of times we do see it like this as well. Sometimes I've never seen it on the ACT, but you could say the length to width, the ratio of length to width. But these are our common two that we're going to see. All right, so let's look at a quick example. All right, let's say there's a class, and in the class there's 12 girls and 10 boys. Okay, so what is the ratio from between girls and boys? Okay, well, the ratio would be 12 girls to 10 boys. Okay, what would the ratio be of boys to students? Well, how many boys are there? There's 10 boys. How many students? There's 22 students, so that would be the ratio. Now, one thing to remember is that these ratios reduce just like a fraction would. So this would actually be 6 to 5, and this would be 5 to 11. And don't forget, a lot of the times we'll see them written like this. Okay, these are very commonly done. We write those ratios as fractions. All right, that's just kind of the basic thing. All right, so if two ratios are equal, they are said to be proportional. So if I have one ratio here that equals another ratio, then I say these two ratios are proportional. Okay, you're going to see this word for sure on the test, the word proportional. Okay, so let's look at an example. If I have 1/4 and 12/48, so some sort of ratio 1 to 4 and 12 to 48. Since those are equal, we would call those two ratios proportional. Okay, so let's look into some more examples of proportional ratios. All right, so first off, let's look at the kind of problems that you're going to deal with proportional reasoning, which is this whole idea of how to deal and solve proportions, deal with and solve proportions. First thing is similar figures, okay? When you're in geometry and you're looking at similar figures, two shapes that are similar, we're going to say that those side lengths are proportional. So in similar figures, the corresponding sides are proportional. Okay, next thing would be a recipe. So when you make a recipe, the proportion of flour to milk should be the same whether you make a big giant bowl of whatever you're making or a little tiny one serving, okay? So with recipes, the ingredients are proportional. All right, another example would just be, it sounds weird, but there are problems where they just tell you that things are proportional. So if they say blah, 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 blah is proportional, then you're dealing with a proportion problem. That seems obvious, but just be aware. All right, the next thing would be rates. A lot of times in rate problems, we deal with proportions. like miles per hour. Okay, that's a rate. So just be ready for that. The last thing would be scale problems. So for example, when you have a map, this little tiny map that represents a much bigger area, they're usually proportional. It's kind of more like similar figures because those maps are representing a proportional amount. So it's kind of like they're similar in shape, but not in size. So we'll look at some examples, okay? All right, so when you get a proportion like this, okay, you get four things. Now, usually they're going to be numbers. I'm just going to use variables. It doesn't really matter. But how do you solve a proportion, okay? Well, what you do is you cross multiply. Anytime you have a fraction equal to another fraction and you're trying to solve, you always cross multiply. Now, remember what that means is the product of these two, remember product means multiply, should equal the product of these two, okay? So A times D. Don't forget that equal sign. A lot of people forget that equal sign in the middle, or they try to put a plus or a minus or something, but it's the product of that, though these two equals the product of these two. All right, so let's look at an example of a problem that you might deal with. All right, so we've got a tree, and the tree casts a 30-foot shadow. Okay, so here's the shadow of the tree. It is a 30-foot shadow, and here is a person, and we know that the person is 6 feet tall, and we know that their shadow is 4 feet tall. 4 feet long. Okay, question is, how tall is the tree? All right, so one thing you probably aren't aware of is that this forms a triangle. All right, the way that the sun's rays come in, they come in at the same angle. So we have these similar triangles. So this is kind of a geometry problem in the sense that these two triangles are similar to each other. All right, so here's how you set up the proportion. First of all, we said proportions are when two ratios are equal. So first of all, I want to set up a ratio. Let's look at the height of the object divided by the length of the shadow. Okay, that's my ratio. So let's look at the first picture, the tree. So we don't know the height, so we're going to use a variable there. Okay, but we do know the length of the shadow. So there's the ratio for the tree and the tree's shadow. What is the ratio for the person? Well, the height of the person is 6 feet tall and their shadow is 4 feet. So what we're saying is that these are proportional, which means that those two ratios are actually equal to each other. Okay, I've got a fraction equal to a fraction. I always cross multiply to solve this. So 6 times 30, that's 180. That should equal 4 times x. 4 times x is 4x. Remember, we don't write the times symbol, but it's there, 4 times x. It's pretty simple. We divide by 4 on both sides, and if I use my calculator there, I would get that x is 45. Okay, now what is x? X was the height of the tree. Remember, this was the tree and this was the person. So we know that the height of the tree is 45 feet. Okay, now real quickly, a lot of times you can solve these without doing a lot of work. Okay, if you notice that this is 6 feet and this is 4 feet, okay, how are those related to each other? Well, using multiplication, how do you get from a 6 down to a 4? Well, basically you take 2/3 of it, right? You break it into 3 parts, that's 2 and 2 and 2, and you just take 2 of those. Well, if I did the same thing here, some number that 2/3 of it should equal this, well, that number has to be 45. Because if you break up 45 into 3 equal pieces, it's 15 and 15 and 15. If you take 2 of those pieces, you get 30. So sometimes you can actually work these problems by using kind of a different kind of proportional reasoning, which is more about this scale factor, this number that multiplies to get from one of the parts of the ratio to the other part. Should be the same number that you'd multiply the other one to get to the other. Okay? So some people are going to work it like that. And if that doesn't make any sense, don't worry about that. Just focus on the way that we're going to solve these. All right, let's do one example that's sort of similar to that, but a little bit different, okay? It's going to involve a building, okay, and a shadow. So let's say the building is 100 feet tall, and its shadow is 175 feet long. Actually, you know what? Let's scratch this. All right, so if a tree's shadow is 50 feet, okay, the shadow is 50 feet. Then the tree grows 20 feet taller. And now its shadow is 60 feet. Okay, so originally, before the tree grew, it had a 50-foot shadow. Now it grows 20 feet taller, and now it has a shadow of 60 feet. So find the original height of the tree. Okay, so what you would have to do is realize that you need a variable here, some unknown. Let's call x the shadow of the tree. All right, the original shadow. Well, recognize that when the tree grows 20 feet, we could use a different variable for that height. But we don't want to use a different variable if we don't have to. We want to represent with using just an x if we can. We want to use the same variable. So I can actually set up an expression x plus 20. If the height of the tree is x originally, it grows 20 feet, it's going to be x plus 20. Okay, so we'll say the new height. All right, so we're going to set up a ratio. Let's do the height of the tree divided by the shadow length. Okay, so we get the height of the original tree divided by the original shadow length. Well, since they're proportional, this should equal the new height of the tree divided by the new shadow length. Okay, fraction equal to fraction. It doesn't matter that on the right side on top you have an expression. You still do the same thing. Okay, you always cross multiply. X times 60 is 60x. Now here, there's a group. There's multiple parts on top. So when I multiply, I actually have to distribute to both parts. Okay, so 50 times x is 50x. 50 times 20 is 1,000. If I solve for x, if I subtract 50x from both sides, I get 10x equals 1,000. If I divide by 10, I get 100. Now remember, what did we say x was? It says it was the original height of the tree. So it was 100 feet, and then it grew to be 120 feet. And those are the shadows that were cast because of it. Okay, so just be aware that in some of these proportion problems, you're going to have expressions, so you may have to distribute there. Okay. Also, they can use variables only in the expression. They could do something like a plus x over b equals c minus d over t. And they could say, solve for b. Okay, well, it doesn't matter. You just still cross multiply and then you solve for b. So don't be worried if you saw something like that. All right, moving on. Let's talk about a unit. All right, a unit of measurement. So something like feet would be a unit, or miles, or in some weird houses. So how many houses, right? That seems like a strange unit of measurement, but it could be, okay? We'll see some problems like that. So if I involve a rate is a ratio, right, which is just a fraction. It's a ratio of two different units. So when units are different, we're talking about a rate. So that could be miles per hour, feet per second, 1 house per 2 hours. All right, that one's kind of a weird one, but I promise you'll see something like it. All right, it's a unit rate if the number on bottom is 1. So when you hear like, oh, I traveled 30 miles per hour, that's really 30 miles divided by 1 hour. Okay, that's called a unit rate because the number on bottom is 1. And we usually don't even talk about it. We usually just say 30, and then we have the rate next to it, miles per hour. Okay, that really means 30 miles per 1 hour. That's called a unit rate if the bottom number is a 1. Okay, so before we get too in depth into these rates, let's look at some basic formulas here. Rate equals distance divided by time, right? The rate, how fast you were going, how fast you did something, is the distance divided by the time, okay? Now this formula can be rewritten if I solve for different variables. So sometimes you'll see distance equals rate times time, or sometimes you'll see it as time equals distance divided by rate, okay? They're all three equivalent. If you just solve for different variables, you get different versions of that, okay? So let's look at some types of problems that you might be solving when you're dealing with rates, okay? Painting a house, I don't know why, but it's always a house and you're always painting it, but very common that you'll see a problem like that. We'll see problems like when you go uphill or downhill, or into the wind, against the wind, or with the river, against the river. Okay, all these problems are called complex rate problems against the river. All right, finally, a very, very common one is a mixture problem. Okay, these are all very, very similar to each other. And here's the basic fundamental idea with all three of these problems. Okay, you do something in total, and what it is it's the sum of the parts. So if you do the part one plus the part two, maybe there's a part three, but either way, the total is the part one plus the part two. So for example, when you're doing a mixture problem, right, you mix up one part and another part. When you add them together, you get the end result. Okay, and we'll see some examples like this. Now with the painting of a house problem, it's actually one house per total amount of time equals one house per speed plus one house per speed. And we'll see this one with the painting of the house. But both of these are very, very common, and they seem kind of obvious, but sometimes it's hard to really come up with these formulas, so I wanted to make sure that I put them there. All right, so let's look at an example. All right, I paint a house in 3 hours. All right, my friend paints a house in 2.5 hours. So you paint the same size house. I do it in 3 hours. My friend can paint it in 2.5 hours. Question is, how long does it take to paint one house if we work together? Okay, very possible type of question. I paint a house in 3 hours. My friend paints it in 2.5 hours. How long will it take to paint one house if we work together? Okay, so what we're talking about again is these rates, which are ratios of two different units. So one something per something, one something per something. Okay, well, what I can do is I can say that I paint one house in 3 hours. So 1/3. Okay, if you add together my friend who can do one house in 2.5 hours, why am I adding them together? Well, because we're going to work together on this. So if you add our abilities together, we get how long it would take to paint one house in total. So the total time it would take for us to work together. So 1 over my speed plus 1 over my friend's speed equals 1 over the speed that we're going to be able to do this together. Okay, so the word together means we got to add. So basically we're just solving this equation. Okay, this is a great time for my calculator. 1/3 plus 1/2.5. I want to add those two numbers together. Okay, so remember alpha y equals allows me to write a fraction just like I see it. So 1/3 plus 1/2.5. That gives me 0.73 repeating. Okay, so I get 0.73 repeating is equal to 1 over the time it takes. Now, if I can think of this number here as a fraction in disguise, Then I know how to deal with this, right? We know how to deal with proportions. This is just an equal fraction problem. So I cross multiply. 1 times 1 is 1. 0.7 times 3 is 0.7333t. So make sure you set them equal to each other, right? Then I divide out the 0.733. Those cancel, and we're left with this weird number. But if I use my calculator, 1 divided by that number that I just had. So if I use second minus, see the answer? It'll plug that answer. Instead of typing 0.7333, I did it all just by answer. So I get 1.3636. Now, that tells me that t is 1.36. What does that number mean? Well, that's the time it will take for us to paint this house if we work together. It's got to be shorter than 3 hours because I'm having somebody help me. It's got to be faster than 2.5 hours because I'm having somebody help me. So this is the rate that it would, this is the amount of time that it would take, 1.36 hours to paint the house together. Okay, just remember this formula for these sum of rates. So my rate plus somebody else's rate equals the total rate. All right. All right. Another example. Okay, so 2/5 of a gallon of white paint is added to a 5-gallon bucket. A 5-gallon bucket. Okay, then equal parts of blue, green, and white are added till the bucket is full. So equal parts of those 3. Question is, how much is white? How much paint is white? Okay, so let's think about this as the total equals the first part plus the second part plus the third part plus the fourth part. Now, why are there 4 parts here? Well, here's my 2/5 gallon that I put in there. Okay, here's the blue, here's the green, and here's the white. Okay, so if I put 2/5 of a gallon in there, I've got 2/5 of a gallon. I know that there's a 5-gallon total, and I know that these 3 parts are actually equal to each other. Okay, so I can say they're the unknown. So X is going to equal, let's say, the white amount of the 3 parts. So maybe instead of white, I'm going to say it's the green that I put in. Okay, now notice since these 3 parts are equal, I can say X plus X plus X, because the amount of green is the same as the amount of blue, which is the same as the amount of white that I put in. Okay, that's going to give me 3X plus 2/5 equals 5. Okay, now I just need to solve that equation. So I subtract 2/5 from both sides, and then I divide by 3. So I'm going to use my calculator for this. I'm going to do 5 minus, in parentheses, 2/5. Remember, I could have done a vertical fraction. Let's make sure we understand why we're doing that. Right, we're doing that because I want to take away 2/5 from both sides so that this goes away. So I need to know what 5 minus 2/5 is. That's 4.6. So 3x equals 4.6. Then I divide by 3 on both sides. I'll just divide that by 3, and I get 1.53 repeating. So that's x. We'll round it to that. Now, what is the question actually asking? It's asking how much white is in the bucket. So I know that, you know, I had 1.53 gallons of green, 1.53 gallons of blue, and also 1.53 gallons of white. So some people might say, oh, it's 1.53. But don't forget that I also had this 2/5 of a gallon of white. So I've got to add back that 2/5 of a gallon. So I need to take 1.53 and add 2/5 to that. So if I'm talking a decimal, 1.93 gallons. All right. But again, this the reasoning here is that you got to break it up into the total as this part plus this part plus this part plus this part. Okay, that's the way you're going to form the equation to solve to get your answer. All right. All right. So moving on to unit conversion. All right, unit conversion. So remember, a unit is something like miles. Okay, so if I want to go from miles to feet, okay, so let's say I want to know 3 miles equals how many feet. We're going to use a unit conversion. Okay, so before we even do this, maybe let's talk about some of the very important ones that you need to memorize. Okay, you need to know these conversions. There are 5,280 feet in 1 mile. Okay, feet to yards. How many feet are there? There are 3 feet in 1 yard. How many inches in a foot? It's easy, 12 inches in 1 foot. Here's a tricky one. How many centimeters in 1 inch? 2.54. And then how many kilometers are there in a mile? There's 1.6. All right, so basically, if I know miles to feet, I know that there are 5,280 feet in 1 mile. So basically, there's only 2 options here. Do I do 3 times 5,280, or I do 3 divided by 5,280? Okay, one of these is correct, one of these is wrong. Well, you could think about it as, what would you get? This is approximately 16,040. That's not right. It's 15,840. Okay. Does that number make sense? 15,840. Does 3 miles equal 15,000 feet? Yeah, I mean, a mile is pretty long, so there's a lot of feet in there. If you were to calculate this, 3 divided by 5,280, you get a very small number. Is there only this many feet in 3 miles? That doesn't make any sense. So this is obviously out. Okay, so here's one way that I remember it. Okay, it's called the arms trick. If you go from a very big number to a very small number, okay, you're going to multiply. That's what I've got here is these x's. So from big units to small units, you always multiply. Now think about this. We're going from miles to feet. Miles are very big. I'm trying to convert them into very small, so I make sure I multiply. Okay? That's what that is saying. Now what if I went from feet to miles? Let's say 125 feet equals how many miles? I'm going to use that same number, that 5,280. But the question is, do I multiply or do I divide? Well, if you go from a very small to a very big, this is sort of hard to do, but a very big, okay, see how this looks like a division symbol when I put my arms out? My head is like the dot, and there's another dot here, dot, dot, arms. So kind of like here's my arms, here's my head, and you'll have to imagine another dot right there. That's a division symbol. So from small to large, we divide. So I would divide this by 5,200. Okay, this is called the arms trick. Helps with unit conversion. When you go from a very small unit to a very large unit. Now, when I say small and large units, I'm talking about yards to feet. That's big to small, because a yard is big, bigger than a foot. So if a yard is bigger and you're going into feet, you're going from big to small. All right, so if you go from small to large, you divide. If you go from large to small, you multiply. That's just for conversion of units. All right, last thing we're going to talk about, a rate conversion. Remember, a rate is just 2 units. So if I want to go, let's say from, if I want to go from miles per hour, let's say I'm going 3 miles per hour, I want to know how many feet per second that is. Okay, that's a rate. Miles per hour, 2 different units divided. Feet per second, 2 different units divided. Okay, so here's what I recommend. 3 miles per hour. Notice they didn't say a number there, just 3 miles per hour. What's the implied number? Yeah, it's 1 hour. Okay, 3 miles for every 1 hour. So what you do is you extend this line out and you put a couple of these boxes. Sometimes it's hard to know how many boxes you need. But anyway, we want to end up in feet per second. Remember, per means to divide. So that's how I know that it's like a fraction. Okay, when I'm saying per, that's division. All right, so you see how miles are on top? Miles are on top. I want to end up with feet on top. So somehow I need to get rid of miles and make feet appear. So what I do is I do some conversions here. Now, you can change from feet to miles because I know that conversion, right? I've got that right here. I know the number of miles compared to the number of feet. So I can directly do that conversion in one little box. Now, how do you know whether to put feet on top or miles on top? Well, just like a fraction, okay, if I had 2 divided by 2, you see how I can cancel those 2's? If the same thing on top of a fraction as is the bottom of a fraction, you can cancel. So because I have miles on top, I want to put miles on bottom so that I can cancel. Okay, so then you put in the numbers. So there's 5,280 feet for every 1 mile. Miles on top, miles on bottom. Those are going to cancel. Now what am I left with? Now I have feet on top, which is what I want over here at the end. And then I've got hours on bottom. Now I want hours to become seconds, so I need to make that conversion. Okay, so I want to put hours on top because I want that hours on bottom to cancel with the hours on top. And since I know how many hours or how many minutes there are in an hour, I'm going to convert minutes to hours in this box. Okay, I know there's 60 minutes in 1 hour. So I can do conversion from hours to minutes. I don't know how many seconds there are in an hour. Otherwise, I would just do it all in one little box. But since I don't know that, I'm going to do just hours to minutes. So I put my numbers in. 1 hour is 60 minutes. Now see how there's hours on top and hours on bottom? That hours on top will cancel with that hours on bottom. Now, what am I left with right now? Now I'm in feet per minute. Feet are on top and minute is on the bottom. I'm getting closer to feet per second, but I need to get rid of minutes. So what I do is the same thing I've been doing. I cancel what I want to cancel on the other side. So if minutes on bottom, I want to cancel it, I need to put minutes on top. And then do your conversion of that. So 1 minute is 60 seconds. So now let's look. Minutes will cancel with minutes, and I'm left with seconds on the bottom. So look at what rates are left over. Feet on top, seconds on bottom. That's exactly what I want, okay? So in each of these boxes, you should have some kind of conversion rate, all right? You should have feet and minutes, or excuse me, feet and miles, something you know how to change. Hours and minutes, minutes and seconds. Put those numbers in the boxes where they go. Make sure you cancel correctly, okay? Don't cancel 2 things on the bottom. It has to be 1 on top, 1 on bottom. But once you get this done, you get this structure built, then you just multiply across, okay? So now I'm going to do 3 times 5,280, 3 times 5 times 1 times 1. I just multiply all my numbers. Okay. So that's going to be, let's see, I'll use my calculator for this one. 5,280 times 3 gives me 15,840. So that's my top number, 15,840, and then feet is the units that go with that. Now I multiply all my bottom numbers, okay? That is going to be 1 times 60 times 60. That is going to be 3,600. And we have seconds as the unit on bottom. So we have seconds on bottom, feet on top. So that's it. I reduce this fraction, okay? 15,840 divided by 3,600. I can use my calculator for that. Divide that 15,840 by 3,600. I get 4.4. So I can say there's 4.4 feet per second. Remember, this would be 4.4 over 1. So 4.4 feet per 1 second. Well, you can't see what I'm doing that, can you? So what I wrote down here was the answer, 4.4 feet per 1 second. Now remember, we don't usually write the 1. We usually just say 4.4 and then put the units at the end, feet per second, because it's a unit rate. Okay. Now it might be you might need that as a fraction. If so, remember you just do math, enter. That will convert it into a fraction. So 22 feet per 5 seconds is the rate at which we're tracking. Okay. All right. I'm trying to think if I have any other questions. I think that's it. All right. Appreciate you being here. We'll see you next week.